Hey everybody, I'm here to go over the research methods review activities. These should look somewhat familiar to you. We did do something of this nature when we were reviewing for the Unit 2 test so long ago in the beginning of the year. Okay, um, let's go through these together. Psychologists generally prefer the experimental method to other research methods because. Okay, so I had said originally, if you remember only one thing from this unit, it's that experiments are the only thing that can determine cause and effect. And that is because of the following. Because in experiments, you are going to be controlling everything except manipulating this one thing, this independent variable, where the experimental group is going to get a certain treatment and the control group is not. Okay, holding everything else constant, I can be reasonably certain then the independent variable cause changes in the dependent variable. So I'm looking for an answer that has cause and effect relationships in it. Let's see here. Yes, experiments can show cause and effect relationships, as opposed to every other type of correlational or descriptive study that only shows that there is some sort of relationship between variables. GEN collects survey data, so again, that's a correlational study, that indicates that students who spend more time preparing for the AP test tend to score better than other students. It's a very kind of common type of correlational study result that, tend to, are likely to, are related to. GEN can now conclude that studying improves exam grades. That's causal. A relationship exists between studying and exam grades. That sounds pretty good. A significant correlation exists between studying and exam grades. Do we have any sort of data? I don't think so. And is there such a thing as significant correlation? There's statistical significance and a correlation coefficient. Let's not get it twisted. Anyone who does not study will do poorly on the exam. That is causal as well. Better students tend to study more. We don't know about the correlation coefficient, so I can't say that E is correct. So the only answer that makes sense is a relationship exists between studying and exam grades. Okay, so let's go back through this and highlight that. Okay, so remember, correlation does not imply causation. Correlation does not imply causation. Okay, now here's the thing. If you get something like this on the AP exam, which I'm sure you probably will, it's not enough to just write correlation does not imply causation. You have to explain why, okay? You have to explain that it's not a tried and true study in which all of these things are held constant except the independent variable. That a correlational study could have other confounding variables that are going to make it seem like the one variable causes the other, when in reality, it could be something else entirely. Okay, so besides experiments, list other types of research methods below. So what are other types of studies? Okay, we're going to have surveys. Wish that this wasn't stuck. Okay, we'll switch that there. Surveys, naturalistic observation, correlational studies, which we say are things like longitudinal studies, which take place over a long time. Longitudinal. Cross-sectional, which are going to involve different age groups or cross-section of the population all at one period of time. And something known as a cohort sequential, which is going to be different groups of ages followed over brief snapshots of time. Those were covered in the Unit 9 development section. And then lastly, case studies. Okay, so surveys, okay, participant bias. When people, think think that the researcher wants a certain answer, they're going to, respond in that way. Similarly, in naturalistic observation, there's participant bias that people act differently when they know they're being watched. Surveys also have skewed questions, and they have different connotations that underlie, the wording of items that can skew results. Longitudinal studies take a long time. They, take a lot of money. People who drop out over the course of years are different fundamentally in certain ways the people that stay in the study. Cross-sectional studies, there's many confounding variables between or among participants so that it's not as accurate. Cohort sequential is probably the best of them, of those types of correlational studies. Case studies, while they are an in-depth study of an individual or a small group of people, they are going to not be generalizable to the population at large. Okay. Charlotte, a nursery school student, hypothesizes that boys have fights with the finger paints more than girls do. She tests her hypothesis by casually watching the finger painting table for 3 days of nursery school. What method is she using? Naturalistic observation. There we go. Theoretically, random assignment should eliminate sampling error, the need to use statistics. What? No. Concerns about validity? It's okay. Many confounding variables or the need for a representative sample? The answer here is many confounding variables. Okay, we're going to talk about this in more depth in just a moment, but whenever I randomly assign groups, I'm going to kind of cancel out the types of people that are in the control group versus the types of people that are in the experimental group. Okay. In the Lerner Listerine study, we talked about if you had random assignment, you would have a lot of people who have really good tooth habits, in one group, and a number of people who have really good tooth habits in another group. People who eat a lot of sugary candy in one group. People who also eat a lot of sugary candy. So random assignment is going to balance out what we call subject-specific confounding variables. Meanwhile, random sampling. Okay, a random sample is the first thing you do. Okay, when you come up with a study, it's just going to mean that every person in a population has the exact same chance of being chosen to participate in the study at all. Okay. Once you have a random sample, then you randomly assign, just from a computer generated list or what have you, to the experimental and the control conditions. Okay, so picking out of a hat to assign each of 3 classes to an experimental condition, is that truly random? Couldn't people in one class be different than, people in another class? Having a computer generate a random list of 100 high school students, that sounds pretty good. Or approaching any 50 students during 6th period lunch? No. Okay. Random sampling would be 2 only. Okay. Picking out of a hat to assign of each of these classes to an experimental condition, meanwhile, number 1 is actually describing random assignment, a poor example of random assignment. So that's so random. What is the difference between random assignment and random sampling? What is the purpose of each? Random assignment, random sampling means every person in a population has an equal chance of being part of the study. Why do we do it? We randomly sample so that we can be reasonably certain that our sample mirrors the population at large, so that our results are what are called generalizable to the population. Enables us to generalize results, so bad at typing today, sorry, to the population at large. Once I have that random sample, then I randomly assign groups. So based upon who is in that random sample, it just says that means that members of the random sample have an equal chance of being in the control or the experimental group. Okay, and why do we do this? It is going to eliminate subject-specific confounding Okay, so when we did the take-home FRQ for Unit 2, Dr. Kripke and I had said that in the prompt that the first 4 students were placed in the experimental group to arrive to class, and the next 4 were placed in the control group. And that was a design flaw. There was not true random assignment because the types of people who are going to arrive to class first may be fundamentally different than those people who arrive to class later who may not be as conscientious. Therefore, we really have to do things like just having a computer anonymously generate a random list of numbers to assign to an experimental or a control condition, just so that we have groups that mirror each other as much as humanly possible. Okay, here we go. Some psychologists consider Stanley Milgram's obedience studies to be unethical because of which ethical consideration? Improper sampling procedures? No, that would be a design flaw, not ethics. Remember, design and ethics are very different. Ethics deal with morality and protecting your subject's rights. Design flaws deal with the actual design of the study, like picking your sample, not randomly assigning people, only administering the study at a certain time of day or year or what have you. Okay. Risk of long-term harm, we'll keep that. Clear scientific purpose. There was definitely a clear scientific purpose, so we're going to cross that off. Debriefing. Stanley Milgram, they were debriefed afterwards, but as you can imagine, they were deceived. Remember, this was the shocking experiment where you were the learner and the teacher, and as the participant in the study, you were actually the teacher, and you were supposedly shocking these people, when in reality there were just no shocks being given. And then after the study, they were told that it was really measuring their capacity to obey authority blindly. So they were debriefed, and they were debriefed in such a way that it actually made them feel worse. I don't know about you, but if someone sat me down and said, well, that study that we were doing, it really, I know it was unpleasant for you, but it really wasn't that. We were just seeing how bad of a person you are by shocking other people. It would kind of stay with me. Anonymity, they were anonymous. So the answer here is risk of long-term harm. Okay. Knowing that I was capable of inflicting harm to another person, that's long-term harm. Being uncomfortable, not being able to drop out of the study, which is something that you should be allowed to ethically at any time because you volunteer and you have the right to drop out, that's risk of long-term harm as well. Okay. How can you be so unethical? Name the ethical requirements when involving human subjects. No coercion. Participation must be voluntary. Yeah, I couldn't say to you, okay, you're part of this AP Psych class. You have to participate in the study. It has to be voluntary. Okay, then there is a blank. Participants must know they are involved in research and give their consent. That is known as informed consent. Now, can people be deceived in a psychological study? Yes. That doesn't make a study unethical. That, in some capacity, is a requirement for many studies, especially social psychology studies. Anonymity or confidentiality, minimal risk of harm. And then there's another blank. It says, after the study, participants must be told of the purpose and be provided with ways to contact the researchers about the results. That's debriefing. And then for animals, which we didn't really go over too much in the scope of the class, but you have to make sure that the study has a clear scientific purpose, that animals are treated humanely, they're acquired legally, and that they're exposed to the least amount of suffering possible. Okay, in an experiment, Sydney is going to investigate how alcohol affects aggression. The number of alcoholic drinks the subject has is called the. Okay, so there's an independent and a dependent variable in a study. If we're using a term like effect, that is causal, it must be an experiment. So there must be an independent and dependent variable. Let's think for a second to investigate how alcohol affects aggression. Okay, one is the cause, one is the effect. The independent variable is the cause. The thing that we measure as a result is the dependent variable or the effect. So the cause here is the alcohol. The effect is aggression. Okay, the number of alcoholic drinks that the subject has is going to be called the independent variable then. Okay. If you confuse them, right, and you said, like, if I confuse them, and I said that was actually a dependent variable, and then I plugged it into that sentence I told you to plug it into, and I said, if I change the aggression, then the number of drinks of alcohol will change. That doesn't make any sense. What does make sense here is if I change the independent variable, then the dependent variable will change. If I change the number of drinks or the amount of alcohol that a subject intakes, then aggression will change. Remember, the independent variable is like an IV drip. Okay, it is a special treatment that you're administering to those in the experimental group. Okay, in order to ensure that we have the most accurate, reliable measurements, it is imperative to set up operational definitions. Okay, if a study explains exactly how a variable is measured, that is the operational definition of the study. So, for instance, in the attendance question yesterday about, on Monday, about the rating, the opinion scale from 1 to 9, or, of healthy eating, that specific scale, numbered scale, is going to be the operational definition. However the experimenter defines it, if you are required to create your own operational definition, being as specific and precise as possible is going to benefit you greatly. Okay, so in class we said, well, how do you operationally define love? What is love? Baby, don't hurt me no more. And we said, well, it could just be something, physiological, like we measure your sweat response and your heart rate and your breathing. Or it could be cognitive and the number of times you think about someone per day. However that makes sense in terms of a precise measurement, so that you can replicate the study, so that if there are multiple researchers, that they can be looking for the same thing. Okay, Vincenzo conducts an experiment to see whether fear makes mice run through mazes faster. He first selects a sample of 60 mice and then divides them into a control group and experimental group, which cannot be a confounding variable. So the two things that cannot be a confounding variable are going to be the independent and the dependent variable, right? Because one you're manipulating, one you're measuring, right? So fear makes mice run through mazes faster. Let's see how fast the mice are in the start, when the mice run the maze, the population from which he selected his subjects, how frightened the mice are before the experiment, or where the mice run the maze. This is not a confounding variable, the population from which he selected his subjects. Okay, that's just defining, where he got his sample. Confound it. Confounding or extraneous variables are differences between the experimental and control groups other than the independent variable. They have an unwanted influence on the outcome of an experiment. In a study measuring the impact of playing violent video games on the frequency of aggression, what might be a possible confounding variable? Okay, so playing violent video games, you have this thing that, you play violent video games. I'll make I didn't know this could be yellow, but whatever, you make like a controller here, right? And this is like old school, like 90s Nintendo. That is going to create violence. The girl pushes the boy. Linguistic relativity hypothesis. Ha ha ha. Psych jokes abound. Okay, so what could be related to both of these things that, are going to make the relationship look causal when in fact it's just something else entirely? How about just like your home environment, your home life, your parenting style, having, an uninvolved parenting style or a permissive parenting style? Maybe, having a permissive parenting style, and that leads to playing more video games, and it also leads to more aggression, let's say. Okay, so this is a masterpiece. All right. Okay, so moving on. Ooh. Oh, like me here. Let's put mine there. Okay, which of the following coefficients of a correlation, aka correlation coefficients, indicate the weakest relationship between two variables? Okay, remember, correlation coefficients are going to go from -1 to +1. Negative being an inverse relationship, as one variable goes up, the other one goes down. Positive, both are moving in the same direction. It's a direct relationship. Both variables are going up. The number of hours I study is correlated to my grade on the test. Okay, 0 would be a 0 correlation. What -1 and +1 are standing for is the number 100%. So that is the strongest correlation you can have. A negative 0.8 is going to be a stronger correlation than a positive 0.6. The closer you get to either one. The weakest would be the closest to 0. So the answer would be C. Okay, so correlation coefficients indicate the strength and relationship between two variables. They are calculated by a formula that produces a number from positive 1 to negative 1. We don't need to know that number in the scope of this class, okay? That being said, a blank correlation indicates that two variables move in the same direction, positive. Okay, a negative correlation indicates that two variables move in two opposite directions. And then a zero correlation indicates that there's no relationship between variables. Okay, mean, median, and mode. Okay, all measures of central tendency, all averages in some way. Okay, so the median of the following distribution, we're going to put the numbers in order: 3, 4, 6, 7, 9. Okay, let's see this. Let's do this again. I'll just 3, 4, 6, 7. Oh, 2. I missed 2. I was thinking to myself, whoa, there's not enough things. 2, 3, 4, 6, 7, 9. Okay, so what do I do here? There is going to be an even number, so I have to take the average between here. So it's going to be 5. Okay, so mean, median, mode, all measures of central tendency. The mean is the typical average score, meaning the sum divided by, I should just put the number of scores. The median is the average middle score, and the mode is the average most frequent score. Jose hypothesizes that a new drug he has just invented will enhance mice's memories. He feeds the drug to the experimental group and gives the control group a placebo. He then times the mice as they learn to run through a maze. In order to know whether his hypothesis has been supported, Jose would need to use scatter plots, descriptive statistics, histograms, inferential statistics, or means end analysis. Okay. Scatter plots, descriptive statistics, histograms, those are all describing measures of descriptive statistics, which is ways to organize the data. To make a judgment about your data, to figure out whether your hypothesis is supported or whether your results are statistically significant, you are going to use what we call inferential statistics. You are making a judgment about your data. You're not just logging the data itself. Okay, so the purpose of descriptive statistics is to organize data. Okay, the purpose of inferential statistics is to judge the data or see whether it can be generalized to the larger population. Okay, so let's go over this, just a little brief thing about data. Descriptive statistics. How do we organize the data? What are some relevant measurements of descriptive statistics? Well, we're just making it more readable, more understandable, just organizing it in a way that is meaningful. So, measures of central tendency or averages like mean, median, and mode. Measures of variation or variability, how spread out the scores are, like range and standard deviation. Now, standard deviation is a better measure of variability than the range because you can have a very large range. Like someone can get a 0 on a test and someone can get 100, even though most people all scored, let's say, an 80. Okay, the standard deviation is going to be the average distance between each score and the mean. Okay, as opposed to one maybe outlying score and another outlying score. Okay, related terms. Okay. Remember, a normal distribution is where the mean, median, and mode are all the same. There's no skew involved, okay? Normal distribution for intelligence. Mean is 100, standard deviation is 15 on the Wechsler Adult Intelligence Scale, okay? There are certain rules that we know. 1 standard deviation below and above the mean, 68% of the population. 2 standard deviations below and above the mean, 95% of the population. Okay, 3 standard deviations, 99% or 99.7% of the population. Okay, not all distributions are normal. Many are skewed. Okay, and a positively skewed distribution. Okay, typically your mode is less than your median, which is less than your mean. Okay, you are going to have remember what happens on a positively skewed distribution is that it is skewed to the right. Okay, and the mean is pulled in the direction of the outliers. Okay, most scores are going to be low. Okay, more low scores. Now, a negatively skewed distribution is skewed left. Okay, really what's happening here is that, again, since it's skewed left, it is going to be the mean is pulled in the direction of the outliers, because remember, the mean is the score that is most vulnerable to outliers. It is most affected by outliers. Very important to know. Okay, so in a negatively skewed distribution, there are a few outliers that are low that pull the mean to the left. Most of the scores are high, actually. Okay, Sandy, meanwhile, scores a perfect 100 on a test that everyone else fails. If we were to graph this distribution, it would be, okay, well, let's see. She's an outlier and she has a high score as an outlier. Okay, that must have been a positively skewed distribution. Okay, if you need more sort of conceptual help with this, visualize world peas. That's supposed to be a pun, okay? So one way to remember what a positively skewed curve looks like is to visualize a pea lying on its back. Most scores are to the left or the low end of the scale, okay? So you can see over here, most scores, the mode is over here, okay? You rarely feel positive about having taken a test with results that are positively skewed. Why? Because chances are you did poorly unless you are an outlier. Okay. Now let's go back for a second to inferential statistics. Okay, I already have my whole data set. I'm taking my data set now, and I'm judging whether there's going to be a significant difference between the means of two groups. I'm judging whether my data is representative of a population at large. Okay, how do I do this? I do this through a relevant measurement known as the p-value. A p-value is the probability of concluding that a difference in your two groups exist when it does not actually exist. Your two groups being the experimental group and the control group. Because inferential statistics are going to deal with experiments. Descriptive statistics are going to deal with descriptive or correlational studies. Okay? So whenever I see that little letter P, it stands for probability. The probability that the results occurred due to chance and chance alone is less than 0.05. That is the minimal degree of statistical significance in psychology. Okay, so again, statistical significance is going to be a difference that is seen in the means of the experimental and the control groups that is likely not due to chance. Okay, so because if you find that your results are less than, a p-value is less than or equal to 0.05, you can be relatively confident that the study isn't a result of coincidence, like the abundance of confounding variables, that it's due to the careful manipulation of this one thing that you're interested in, or your independent variables effect on the dependent variable. Okay, so hopefully, I'm hoping that that is somewhat helpful. Remember, research methods is going to essentially be 45% of your FRQ score on the AP test. If you don't get this stuff, reach out, attend a live session, email me. Do what you have to do to get it, okay? Because I want you to succeed. All right. Hope you're well. Bye-bye.